Hi and welcome to the third section of this video course. This section is about how to approach machine learning problems, and this video in particular provides an overview on scikit-learn. Before digging into the details, let's have an overview on the section. So in this section, we'll first introduce scikit-learn as main tool to tackle machine learning problems using Python. We'll then discuss some of the most common tasks in machine learning. In particular, we'll see how to perform regression, which is the task of predicting a quantity. Next, we'll move on with classification, the task of assigning a class or a category to a particular item. And finally, we'll look into clustering, which is the task of grouping similar items. Each individual video will provide more details on these problems, and will show you how to approach the problem using scikit-learn and Python. And now we're ready to start with the first video of the section and have an overview on scikit-learn and machine learning, introducing some of the terminology. So in this video in particular, we'll introduce the library and some high-level notions of machine learning. We'll look into the main components of scikit-learn, and we'll see how we can use them to solve a machine learning problem. Scikit-learn is the main Python library for machine learning. It provides a simple-to-use abstraction, hiding the low-level details of its efficient implementation. It offers an out-of-the-box implementation of many machine learning algorithms for classification, clustering, regression, dimensionality reduction, as well as tools for data preprocessing, model selection, and evaluation. It's built on top of NumPy, SciPy, and Matplotlib, bringing together the Python stack for scientific computing. The library comes with options for an easy access to data. In particular, some of the standard well-known datasets, like the Iris dataset or the Boston House Prices dataset, are already included in scikit-learn. The library also provides the access to other common datasets. Scikit-learn provides the facilities for data transformation activities like feature extraction, standardization, normalization, and binarization. These notions of data transformation are more or less standard in machine learning, and scikit-learn simply offers an easy-to-use implementation. Also in terms of implementation, scikit-learn comes with many algorithms for supervised and unsupervised learning. One of the reasons for the success of scikit-learn is the simple-to-use and coherent interface, which we're going to see in a moment. In terms of model selection and evaluation, scikit-learn provides implementation for cross-validation, parameter tuning, as well as evaluation metrics. If you're new to machine learning, most of the terminology on this slide is probably also new for you, and it could be a bit overwhelming. The purpose of this section anyway is not to give you a comprehensive overview of machine learning, but simply to give you the basic tools to tackle some of the most common problems using Python. So at this point the message is scikit-learn as a library provides support for an end-to-end machine learning pipeline. So the first step when doing machine learning is always to understand the problem and scope it correctly. As an overview, the main problems that we're going to discuss also in the upcoming videos are the following: regression, which is the task of predicting a quantity; classification, which is the task of predicting a class, or if you prefer, assigning an item into a particular class; and clustering, which is the task of grouping items that belong together. Just to give you the overall flavor of the scikit-learn interface, the first step is to get the data in the right shape, so you can feed the data to the machine learning algorithms of your choice. This is commonly done through one of the vectorizers using their fit-transform function. After getting the data in shape, we need to choose the machine learning algorithm for our task, also called an estimator. And for the training phase, all we need to do is to call the fit function against our training data. After training the estimator, we can perform the prediction by calling the predict function against the test data. So this is the overall idea of approaching a machine learning problem with scikit-learn. Of course, we'll tackle specific problems in the next videos. If you want some help to choose the right algorithm for you, you can Google for the scikit-learn cheat sheet, and the link is at the bottom of the slides, and follow the instruction. So this is the scikit-learn cheat sheet. It's a good starting point if you don't know how to choose an algorithm for your problem. As you can see in the flowchart here, if you have less than 50 samples, you should try to get more data. It's quite common to have thousands, if not millions of samples. Then from here, if you're predicting a category or a class and you have label data, then it's a classification problem. Later we will look at some of the options. If you don't have label data, you just want to group items together, it's a clustering problem. On the other side, if you're predicting a quantity, that will be a regression problem. And if you click on one of the boxes mentioning the algorithms, then there is a link to the relevant documentation for the specific algorithm, so you can check out the details. So in summary, we have introduced the library scikit-learn. The reason for this lengthy introduction is that there are many components in this library, but all in all, it's fairly easy to use, and this is thanks to its clean and coherent interface. We also mentioned how the library supports the whole end-to-end machine learning pipeline with tools for data transformation, the machine learning algorithms, tools for model selection, tuning, and evaluation.